In 2024, a startling announcement rocked the global economy. As astrophysicist Neil deGrasse Tyson had predicted, the first trillionaire there will ever be is the person who exploits the natural resources on asteroids. That prediction was about to become reality. The numbers were staggering. The asteroid mining market was projected to surge from $1.68 billion in 2024 to approximately $2.7 billion by 2025, reflecting a robust compound annual growth rate of 23%. But these figures represented just the beginning of what would become the greatest economic transformation in human history. Dr. Sarah Chen, a 29-year-old mining engineer and planetary geologist from the Colorado School of Mines, stood in the Mission Control Center of Asteroid, a California-based startup that had just achieved the impossible. On her computer screens, telemetry data streamed from the Vestry probe, humanity's first commercial spacecraft to successfully dock with a metallic asteroid 22 million miles from Earth. The asteroid designated 2024 MX had been discovered 18 months earlier by NASA's automated tracking systems. Initial spectroscopic analysis revealed something extraordinary. This 800-meter-wide space rock contained an estimated $40 billion worth of platinum group metals, rare earth elements, and gold. More platinum than had ever been mined in human history. More gold than existed in all of Earth's central bank reserves combined. Sarah had joined Asteroid in 2023, fresh from completing her PhD in planetary resource extraction. Her dissertation on autonomous mining systems in zero-gravity environments had caught the attention of Asteroid CEO Matthew Giolic, who was assembling the world's first commercial asteroid mining team. The company's mission was audacious. With a finite supply of precious metals on Earth, we have no other choice than to look to deep space to source cost-effective and sustainable materials. What made Asteroid different from previous failed attempts was timing and technology. SpaceX had revolutionized launch costs with reusable rockets. Advanced AI could now operate mining equipment autonomously across interplanetary distances. Most importantly, several near-Earth asteroids had been identified that contained more valuable resources than entire countries. Sarah's job was to design the mining systems that would extract these treasures from space. The challenges were unlike anything faced by terrestrial mining. No atmosphere meant no oxidation or weathering. Metals existed in their pure forms. No gravity meant materials could be extracted without fighting against gravitational forces. But it also meant that every piece of equipment had to operate in the harshness of space, radiation, extreme temperatures, and the vacuum of space itself. The Vestry mission was the culmination of 3 years of preparation. The 440-pound probe had launched as a rideshare passenger on Intuitive Machines' IM-3 lunar mission, then used its own propulsion system to travel to Asteroid 2024 MX. The journey took 8 months, during which Sarah and her team monitored every system, made course corrections, and prepared for the most expensive mining operation in history. The asteroid itself was a geological marvel. Unlike Earth rocks that had been processed by billions of years of weathering and geological activity, 2024 MX was a pristine remnant from the solar system's formation 4.6 billion years ago. Spectroscopic analysis revealed that it was a metallic M-type asteroid, composed primarily of iron and nickel, but shot through with veins of platinum, palladium, rhodium, and gold that had never been contaminated by terrestrial processes. Sarah's mining system was elegantly simple in concept, but revolutionary in execution. The Vestry probe carried a small swarm of autonomous mining robots, each about the size of a coffee table. These robots used focused laser arrays to heat and fragment the asteroid's surface, while magnetic collection systems gathered the resulting metallic particles. The entire operation was controlled by an AI system that could adapt to changing conditions without waiting for communications from Earth, which took 12 minutes each way. The first samples were collected on a Tuesday morning in March 2025. Sarah watched the telemetry in real time as Robot 1 began its laser cutting sequence. The laser heated a small section of the asteroid's surface to over 3,000 degrees Celsius, causing the metal matrix to fracture and release particles rich in precious metals. The magnetic collectors immediately swept up the material, storing it in sealed containers aboard the Vestry probe. Within 6 hours, the probe had collected 50 kilograms of the highest-grade platinum ore ever discovered. At Earth prices, That sample was worth 2.8 million, but this was just the proof of concept. The real prize would come from full-scale mining operations. News of the successful sample collection sent shockwaves through global financial markets. Platinum prices dropped 15% in a single day as traders realized that asteroid mining could flood the market with precious metals. Gold futures fell 8%. But simultaneously, stock prices for space companies soared. Astroforge's valuation increased from $500 million to $3.2 billion overnight. Sarah found herself at the center of a media storm. CNN, Fox News, CNBC, and international networks all wanted interviews with the woman who had designed humanity's first space mining system. The headlines were sensational. The 29-year-old who could become Earth's first trillionaire. Space gold rush begins. The end of scarcity. But Sarah knew the real work was just beginning. The Vestry probe could collect samples, but full-scale mining would require much larger operations. Her team was already designing the next generation, the Odin-class mining platform, a spacecraft the size of a small office building that could extract thousands of tons of material from a single asteroid. The economics were staggering. Earth's annual platinum production was about 200 tons, worth approximately $6 billion. A single medium-sized metallic asteroid contained more platinum than had been mined in all of human history. The potential wealth was almost incomprehensible. But Sarah understood that the real revolution wasn't just about making individuals wealthy. Asteroid mining would fundamentally transform human civilization. With unlimited access to rare metals, technologies that were currently too expensive to implement could become commonplace. Electric vehicles could be mass-produced without concern for platinum supply constraints. Solar panels and wind turbines could be manufactured on a scale that would make renewable energy cheaper than fossil fuels. The electronics revolution could accelerate exponentially. The environmental implications were equally profound. Earth's ecosystems would no longer need to be destroyed for mining operations. The environmental cost of a single large open-pit mine could be eliminated by extracting equivalent resources from a single asteroid. As one researcher noted, mining and returning platinum or gold from asteroids could make a person a trillionaire overnight, with the potential to flip our entire economy, trade, and market. While Vestry continued its sample collection mission, Sarah was already working on the next challenge: transportation. Getting materials from asteroids back to Earth economically required revolutionary spacecraft design. Traditional chemical rockets were far too expensive. Her team was developing a new class of cargo vessels that would use ion propulsion for the slow journey back to Earth, powered by solar arrays unfurled in the vacuum of space. The cargo vessels would be massive, each one capable of carrying 500 tons of processed metals. They would make the journey from asteroid to Earth in 18 months, arriving at a processing facility that Astroforge was building at the L5 Lagrange point, where Earth and Moon's gravity balanced out. At this facility, raw asteroid materials would be refined into pure metals and then transported to Earth via smaller, more maneuverable spacecraft. By late 2025, Astroforge had identified 12 prime asteroid targets within reach of their technology. Each asteroid contained different mineral compositions, allowing for a diversified mining portfolio. Asteroid 2025 Jux contained the highest concentrations of rare earth elements ever discovered, materials essential for wind turbines, electric vehicle batteries, and advanced electronics. Asteroid 2024 RB was almost pure platinum and palladium. Asteroid 2025 ZM contained water ice that could be split into hydrogen and oxygen, creating the first space-based fuel depot for deep space missions. The success of the Vestry mission triggered a global space mining race. Blue Origin announced Project Golden Fleece, aimed at mining Asteroid 2026 QR for gold and platinum. SpaceX revealed that they had been secretly developing asteroid mining capabilities for 2 years, with plans to launch their first mining mission in 2026. Even traditional mining companies like BHP Billiton and Rio Tinto announced partnerships with space companies to enter the asteroid mining business. International governments scrambled to create regulatory frameworks for space mining. The US had passed the Commercial Space Launch Competitiveness Act in 2015, granting American companies rights to resources they extracted from asteroids. Luxembourg had created similar legislation and positioned itself as a European hub for space mining companies. But as the industry moved from theoretical to operational, new legal challenges emerged. Who owned the resources from asteroids? What happened if multiple companies targeted the same asteroid? How would asteroid mining affect Earth's economy and existing mining communities? Sarah found herself testifying before Congress, explaining the technical realities of space mining to senators who struggled to understand the magnitude of the transformation ahead. The geopolitical implications were enormous. Countries with large mining industries, Australia, Chile, Russia, South Africa, faced the prospect of their primary export industries becoming obsolete. Nations that had been mineral poor could suddenly become wealthy by developing space mining capabilities. The entire global balance of economic power was shifting. Sarah's personal life changed dramatically as well. She was named to Time magazine's list of the 100 most influential people. Her net worth, primarily in Astroforge stock options, had increased over $200 million. Venture capitalists, tech billionaires, and world leaders sought meetings with her, but she remained focused on the technical challenges ahead. The Odin-class mining platform represented a quantum leap in capability. Unlike the Vestry probe, which was essentially a sophisticated sample collection mission, Odin would be a full industrial facility in space. The platform would be assembled in Earth orbit from components launched by SpaceX's Starship rockets, then use nuclear electric propulsion to travel to target asteroids. Once at an asteroid, Odin would deploy an array of mining robots, processing equipment, and storage containers. The platform could operate autonomously for up to 5 years, continuously extracting and processing asteroid materials. Advanced 3D printing systems would manufacture tools and replacement parts from asteroid metals, making the operation largely self-sufficient. The first Odin platform was scheduled for launch in 2027, with a target of asteroid 2024-2MX, the same asteroid where Vestry had proven the concept. Sarah calculated that a single Odin mission could extract 10,000 tons of platinum group metals, worth approximately $400 billion at current market prices. Even accounting for the massive development and operational costs, the profit margins were extraordinary. But the real breakthrough came when Sarah's team solved the transportation economics problem. Instead of bringing raw materials back to Earth, they would establish orbital refineries that processed asteroid materials in space. These refined metals could then be used directly for space-based manufacturing, eliminating the enormous cost of lifting materials from Earth's gravity well. This led to Sarah's most audacious vision: space-based manufacturing at unprecedented scale. With unlimited access to metals from asteroids, enormous manufacturing facilities could be built in space. These factories would produce everything from spacecraft to electronics to solar power satellites, all using materials extracted from asteroids. The products could be used in space for further development or delivered to Earth at costs far below terrestrial manufacturing. By 2028, 3 years after the first successful asteroid mining mission, the industry had exploded into a $50 billion market. Astroforge had completed 5 successful mining missions and was operating 2 Odin-class platforms. Their closest competitor, Asteroid Resources Inc., had launched their own mining operation targeting water-rich asteroids to supply the growing space-based fuel industry. Sarah, now 32 and Astroforge's chief technology officer, oversaw a team of 3,000 engineers and scientists. The company operated 12 spacecraft, 3 orbital processing facilities, and had mining rights to over 200 asteroids. Her personal net worth had exceeded $2 billion, making her one of the youngest billionaires in history. But the true transformation was just beginning. The abundance of space-based resources had triggered an explosion in space-based economic activity. Orbital manufacturing facilities employed thousands of workers. Space-based solar power satellites, built entirely from asteroid materials, beamed clean energy back to Earth. Tourism to asteroid mining facilities became a billion-dollar industry in itself. The environmental benefits were profound. Earth's mining industry had been largely replaced by space-based extraction. Rainforests were no longer cleared for mining operations. Water supplies were no longer contaminated by mining runoff. The planet's ecosystems began to recover as humanity's resource extraction moved off-world. Economic disruption was equally dramatic. The price of precious metals had crashed as asteroid mining flooded markets with supply. But this had positive effects. Renewable energy technologies became so cheap they displaced fossil fuels entirely. Electric vehicles cost less than gasoline cars. Advanced electronics became affordable for everyone on Earth. Traditional mining communities faced challenges as Earth-based mining became uneconomical, but the space mining industry created new opportunities. Former coal miners became spacecraft technicians. Geologists became asteroid prospectors. Mining engineers like Sarah became some of the most sought-after professionals in the rapidly expanding space economy. By 2032, Sarah was leading Astroforge's most ambitious project yet, the development of Ceres Station, a permanent mining colony built into the dwarf planet Ceres in the asteroid belt. The station would house 10,000 residents and serve as the hub for mining operations throughout the asteroid belt. Entire families would live and work in space, supported by the wealth extracted from countless asteroids. Sarah often reflected on how quickly everything had changed. 5 years earlier, asteroid mining had been considered science fiction. Now it was the foundation of a new space-based economy that employed millions of people and generated trillions of dollars in wealth. The first trillionaire had indeed emerged from asteroid mining, though it wasn't a single individual, but rather humanity itself that had become wealthy beyond measure. Standing in her office aboard Ceres Station, looking out at the asteroid belt where dozens of mining operations harvested the resources of countless worlds, Sarah could see the future of human civilization. It was a future where scarcity was obsolete, where the resources of an entire solar system were available to support human flourishing, and where the dreams of wealth beyond imagination had become reality among the stars. The asteroid gold rush had begun with a single sample collected by a coffee table-sized robot. It had transformed into the greatest economic revolution in human history, and Sarah Chen, the mining engineer who had designed humanity's first space-based extraction system, had helped lead the charge into an age of abundance that would last for thousands of years. The stars were no longer distant lights in the sky. They were destinations where infinite wealth waited to be discovered, extracted, and shared among all humanity. The first trillionaire had been found not in a person, but in the limitless resources of space itself.